Circulation. How do open and closed circulatory systems compare? In an open circulatory system, blood is only partially contained within a system of blood vessels as it travels through the body. The tubular heart only partially is contained within the blood vessels. In a closed circulatory system, blood circulates entirely within the blood vessels that extends throughout the body. Pulmonary capillaries go through the lungs, oxygenate the lungs. Red represents oxygenated blood, goes into the left atrium, and then is pumped through to the left ventricle and on through to the body, the systematic capillaries, through arteries, returns to the heart through the veins, and back around into the right atrium, pumped through right ventricle back into the pulmonary capillaries to continue the cycle. Many animals move blood through their bodies using one or more hearts. A heart is a hollow muscular organ that pumps blood around the body. A heart can be part of either an open, typically invertebrate, or a closed, typically vertebrates, circulatory system. In an open circulatory system, blood is only partially contained within a system of blood vessels as it travels throughout the body. Arthropods and most mollusks have open circulatory systems. So the heart is here. There's more than one heart pumping, and the blood vessels are here. And the heart pumps through here and it releases back into the system and back into the hearts, one of the hearts. So each of these are small hearts for circulating the inner fluid. One or more hearts or heart-like organs pump blood through vessels that empty into a system of sinuses or spongy cavities where blood comes into direct contact with body tissue. Blood then collects in another set of sinuses and makes its way back to the hearts. In a closed circulatory system, blood circulates entirely within the blood vessels that extend throughout the body. Many larger, more active invertebrates, including annelids and some mollusks, and all vertebrates, have closed circulatory systems. A heart or heart-like organ forces blood through vessels. This is a heart-like structure, pushes the blood this direction through the systems, small vessels in the tissue for exchange, oxygen with carbon dioxide, other fluid exchange. And these are the heart-like structures. There's more than one in this annelid, and here are the blood vessels. Nutrients and oxygen reach body tissues by diffusing across thin walls of capillaries, the smallest blood vessels. Small blood vessels here. Blood that is completely contained within blood vessels can be pumped under higher pressure and circulated more efficiently than can blood in an open system. How do patterns of circulation in vertebrates compare? Amphibians, reptiles, and mammals. Most vertebrates with gills have single loop circulatory system with a single pump that forces blood around the body in one direction. Single pump systems are common in fish. Most vertebrates that use lungs for respiration have a double loop, two pump circulatory system. Most vertebrates with gills, commonly fish, have a single loop circulatory system with a single pump that forces blood around the body in one direction. Here's the heart. One ventricle pushes into the gill capillaries to oxygenate the blood, goes through to body capillaries to exchange oxygen for carbon dioxide and to deliver nutrients and remove waste, returns back to the atrium and then back to the ventral again to continue the cycle, exchanging in the gills to get rid of waste and receive oxygen. In fish, for example, the heart consists of two chambers, an atrium and ventricle, an atrium and a ventricle. The atrium receives blood from the body. The ventricle then pumps blood out of the heart and to the gills. Oxygen-rich blood travels from the gills to the rest of the body. Oxygen-poor blood then returns to the atrium. Most vertebrates that use lung for respiration have a double loop, two-pump circulatory system. Two pumps. The first loop of circulatory system is powered by one side of the heart and forces oxygen-poor blood from the heart to the lungs. From the heart to the lungs. Lung exchange from the capillaries back to the heart, into the atrium, and then the ventricle, back around to the body, capillaries, back around to the heart, the atrium, and back to the ventricle, continuing the cycle. The first loop, powered by one side of the heart, forces oxygen-poor blood from the heart to the lungs. After the blood picks up oxygen and drops off carbon dioxide in the lungs, it returns to the heart. The other side of the heart pumps oxygen-rich blood through the second circulatory loop to the rest of the body. Amphibian hearts usually have three chambers, one atria and one ventricle. The left atrium receives oxygen-rich blood from the lungs. The right atrium receives oxygen-poor blood from the body. Both atria empty into the ventricle. This atria and this atria both enter into one ventricle. Some mixing of oxygen-rich and oxygen-poor blood does occur, but the internal structure of the ventricle directs blood flow so that most oxygen-poor blood goes to the lungs and most oxygen-rich blood goes to the rest of the body. Oxygen-rich goes back and somewhat oxygen-poor goes to the lungs. Reptilian hearts, like that of the crocodile heart shown, typically have three chambers, two atria and one ventricle, like the amphibians. However, most reptiles have a partial partition in the ventricle, resulting in less mixing of oxygen-rich and oxygen-poor blood than there is in the amphibian heart. So in this case, there's less mixing because there's more of a barrier here, a partial partition. Here, there's less of a partition. So in summary, the closed circulatory systems for a three-chambered heart in amphibians, and a three-chambered separated heart for turtles, and a four-chambered completely separated birds and mammal. So for the three-chambered heart, mixed oxygen goes to the lungs, exchanged for oxygen-rich. That is pumped to the body, and then oxygen-poor is pumped back to the heart and mixes and continues the cycle. A three-chambered separated for turtles, for instance. So for reptiles, the mixed portion of the blood, oxygenated and unoxygenated, is less mixed and continues the same cycle as the amphibians. For birds and mammals, there is no mixing. One direction goes from the heart. Unoxygenated blood goes to the lungs, exchanges. Oxygenated blood goes to the body, returns unoxygenated, and the cycle continues.